Hello everyone, welcome back to the course on cryptography and network security. So myself Dr. Janardhan Adia. So in today's class we try to understand how to solve an RSA algorithm. So in order to perform the encryption and decryption process. So in today's class we try to understand introduction to the cryptography, what is an RSA algorithm. So the key concepts behind the public and as well as the private key, and the various steps which is involved in RSA algorithm, the key generation, that is for the encryption key and as well as the decryption key, and the process of performing the encryption and the decryption, and we try to solve one worked example, and at last we are going to be discussing on the various advantages, limitations, and the real world applications of RSA algorithm. The learning objectives: by end of this video learners will be able to understand the concepts of public key cryptography, and they will be able to explain how the RSA algorithm is going to work and performing the key generation of RSA, and they'll be able to apply the encryption and decryption steps after calculating the key generation, and they will be able to solve numerical problems on RSA, and also they're going to be identify the real world applications of RSA. When it comes to introduction to RSA, so RSA is an asymmetric cryptographic algorithm. So the RSA stand for Revest, Shamir, and Adelman. So these three people are invented this algorithm. That's why the starting character of their names, they have been kept it as an algorithm name, that is RSA algorithm. So this algorithm is going to be make use the two different keys, the one for encryption, the another one for decryption. So for encryption key we call it as a public key. Anybody knows the public key of any user, they can able to perform only the encryption, and the private key we are going to be used for decryption. So developed by Reves Shamir Adelman in the year 1977. So it is going to be used in secure the communication, so HTTPS, digital signatures, banking transactions. The basic concepts behind this RSA algorithm is: sender encrypts the message using the receiver's public key, and the receiver decrypts using private key, their own private key. It is mainly based on prime factorization problem. We are going to be choosing the large prime number, so it becomes very hard to break. So now we try to understand the various steps which is involved in RSA algorithm. So we have to be go on choose the large prime numbers. When we go for implementing practically and all, we have to be go on choose, but when we go for understanding for the educational purpose and all how the RSA algorithm works, we are going to be choosing the smaller prime numbers. So the very first step is choosing the two prime numbers, we call it as P and Q. Then we need to be go on compute n, that is the product of two prime numbers, and then we need to be go on calculate the Euler's Totient function, that is phi of n, p minus 1 into q minus 1. Then we have to be go on choose the public key. So that public key is nothing but E. So what is the condition to choose the public key? So what will be the range, between what range we can able to choose the public key? So it should be greater than 1 and less than the totient function. So then also the GCD of the encryption key, that is public key, and the totient function should be equal to 1. Then we will be go on computing for to get the private key called D. So D into E congruence to 1 modulo of totient function n. So this is how we are going to be calculating the decryption key. So now we try to understand with one worked example here. So the key where the prime numbers we are going to be choosing for P and Q will be 3 and 11, the two prime numbers. Then we are going to be computing the product of two prime numbers, 3 cross 11 33. Then we are going to be calculating the totient function phi of n, that is 3 minus 1 into 11 minus 1, 2 into 10 20 c. Now we are going to be choosing one the co-prime number. So between 1 to 20. So between 1 to 20 we are going to be choosing the 3. So 3 and 20. So greatest common divisor will become equal to 1. So in such a way we have to be going to choose the public key, that is E value. Then we have to be go and find out the decryption key, that is private key and all. So as the equation says, D into 3 congruence equal to 1 mod 20. So I need to be go and choose in a serially, that is by substituting 1. So 1 cross 3, so 3 mod 20 means, so the remainder will be 3 only. Then 2 cross 3 6, remainder 6. So I need to be get the remainder 1. In such a way we have to be go and choose the value for D. So 3 cross 3 9, again the remainder will be 9 only. Then 4 cross 3 12, again 12. 5 cross 3 15, 6 into 3 18, 7. So when it multiply with 7 into 3, it becomes 21. When I perform the modulus with 20, I am able to get the 1 as a remainder. So it is going to be satisfying the condition. So I'm going to be choosing D is equal to 7. So now here I'm representing. So public key will be 3 comma 33 and private key will be 7 comma 33. So now when I go for encryption process, the equation for the encryption is C stands for ciphertext, M is the message. So I'm going to be use the public key. So mod n. So C is equal to M to the power of E mod n. So if I'm going to be considered M is equal to 4, then C is equal to 4 to the power of 3 mod 33. So I'm going to be get 64 mod 33. The remainder will become 31. So this 31 will become the ciphertext for the given message 4. So this is how we are going to be performing the encryption. So when it comes to decryption, I wanted to get back my plain text, that is 4. So M is equal to ciphertext to the power of D, that is private key mod n. So M is equal to 13 to the 31 to the power of 7 mod 33. I am able to get back my message M is equal to 4. So now we try to understand what are the various real world applications, advantages and the limitations. So when it comes to the applications and all, secure web browsing, HTTPS, email encryption, digital signature, online banking, and even in the case of VPN security, we are going to be use the RSA algorithm. Advantages: highly secure, no need to share private key, widely used standard. And the limitation is slow for the large data. When you go for encrypting on a large data and all, it takes more amount of time. So it requires the larger key sizes because, as I mentioned, so prime factorization. So in order to make hard to break this algorithm and all, we have to be choose the large prime numbers. And vulnerable if prime numbers are small. So that is the drawback of this particular algorithm. We are not supposed to choose the small prime numbers and all. So with this, I'm going to be concluding this session. So at the end of this session, so RSA uses the public and private key for encryption and as well as the decryption. So mainly the security is based on the factorization problem. So how large prime number you want to be choose, so that much stronger your algorithm. So and this RSA includes the key generation. So that is nothing but obtaining the encryption key and the decryption key. Then we have to be gone perform with the encryption and decryption process. So with this, so I'm going to be ending this session. Thank you.